we are anything you remember from last time? We started virtualization last time, right? Tell me any one word that you recall from last time. Theory, yeah, that's good. That's for distributed system. Excuse me. Can anyone tell me what CAP theory CAP stand for? Either Ankita or anyone else? So that was on the data center overview section, performance, the metrics evaluation, and also some of the operation issues. How about Venkat Hasai? This is the open note, right? What does CAP stand for? Come on, just C for consistency,
Availability and
A for
partition tolerance.
thank you. Yeah, availability and partition tolerance. Okay, anything else you remember, you guys remember from last time? So again, data center overview, the operational issues, uh, the OPEX, the performance metrics. And we have talked about availability techniques, right? I believe that was on the quiz as well. Hope, it was, good. I hope you didn't feel difficult, right? Some operational tips, keeping things simple, keep it simple and stupid, kids, the principle. That's what we have talked about. And in terms of virtualization, okay, what do you remember from last time? Yes, once virtual machine, right? What was the another name for virtual machine monitor? Yes, we also talked about the guest operating system and host operating system. Anyone remembers another name for virtual machine monitor? VMM. Come on. Havan. It ends with a visor. Another name for, yes, hypervisor. Thank you, Ankita. I really want to solicit, the others, the responses too. Avinav, yes, thank you. Okay, so let's get it started. So entire machine can be virtualized. That includes the operating system, right? So the applications often depend the way it is the execution file is generated is really through the operating system. So application will be dependent on the OS. With a virtual machine, entire machine can be virtually implemented. And that is again through this thin software layer called EMM. Hypervisor is another name. The virtualization can be really useful for various things. We talked about consolidating resources, system management can be improved, software lifecycle can be improved, and it can increase the availability as well, as it can easily scale up or down, and also when something fails, it can replicate it easily. So let's go talk about a little more detail about the consolidation. Excuse me. So here it is not just a server consolidation, but it is also client consolidation as well. The number of physical servers can be reduced because if you put things in all different machine or different beam, some things can be underutilized. Therefore, the putting things consolidated, the systems, the servers can be better utilized, reducing the total number of servers. Then also related power, space, cooling cost will be reduced. When consolidation was really becoming a big boom in industry in, say, early mid 2000, the or even late 2000, just before the cloud computing, even in the beginning of the cloud computing, the consolidation has been really big buzzword at the time. Whenever we had a advisory board from industry members with the school, they help give comments on our curriculum. They keep talking about the consolidation, consolidation, consolidation. So that was a way to reduce the cost that we have all the time. In terms of client consolidation, it is more on the to the development. It has to be tested on multiple OS versions, OS types and OS versions. And distributed system, it has to be tested, sending, receiving, all those. We do need a multiple machines for any networked application, meaning cloud applications. So rather than having individual machines for each of those, we can have a single machine, virtual implementation, virtual machines for each of those. So it can reduce, again, space and all of the costs relating to that. And also managing will be easier as well. Once a developer have to change a machine from one to another, you need a big space on your desk, switching from one node, one machine to another. It can be just, one click away. So consolidation here, both in terms of client and servers. In terms of system management, by the way, all these the benefits of having virtualization, it makes good sense, of course, in terms of system management, by the way, all these the benefits of having virtualization, it makes good sense. Of course, once you read it, once you hear it, I want you to try to think on your own. What are the more specific factors or elements, cases where virtualization can benefit, right? So consolidation, we can also look at the not just in general consolidation, server side and client side as well. What about system improvement, management? Of course, in the data center, I want you to they have your own thoughts and feel free to type in on this chat, right? Data center management will be, by having this data center cloud computing operation, it's really through the virtualization. It's again the engine of the cloud computing, and it makes all the management of the system easier. The see this virtual machine can be portable, moving from one to another server, physical server, and migration, the while it is operating, it is also possible. So that's called the live migration, and this is really key enabler for data center cloud computing. Resource scheduling can be a lot easier to do. any system management is a big issue. The network management is a part of my big research area, and how to do the management better. These days, how to use AI for network management. Yeah, so that's a big topic, and the having everything pulled together, gathered together, will be easier to do the assignment. Here's a task, which server they will run the application. That's management resource allocation is uh, easier. And then just the overall, the you um the by having everything together, you can improve the performance, optimize the performance. Energy consumption can be reduced. Um, New application can be allocated easily. An application, again, it can be migrated while it's operating. So downtime will be either eliminated or reduced. That's for big data center management, and even for desktop management in the university setting, remote desktop, it's easier to do it. In older times, just before the semester starts, the IT personnel have to have several work studies. So we have a less work study students for that these days. They having each machine, in really older times, every individual applications necessary for classes has to be installed separately. Later, it was made as an image and just downloading the image, copying that image for each machine. But still, it used to be done in physical machine one by one. Nowadays, IT staff can everything remotely. So the not only big data center, but also smaller enterprise, the desktop management has become easier. The 10 times better efficiency, this is actually really big number, not like 10%, 5%, 10 times increase in system admin efficiency. This is a really big one. And in fact, it can be more than that. And now you cannot even imagine this management going back to the older system, the format style. As a developer, you can imagine that all this cycle of development, debugging, deployment, maintenance can be done in one physical machine, in virtual machines. This is really powerful tool for software developers. You can trace application behavior easily. The easily model distributed system in a single machine. For our research purpose too, we do network emulation, distributed system, blockchain emulation. It is all, we don't have to have a, real cluster or distributed systems deployed in different places. We can do it all using virtual machines. And because OS can be flexible, different versions of the same OS or different the OS can run it. Different flavors of Linux system, you can run it easily. So the execution environment, on top of those application can be flexible as well. So these are again the benefits of virtualization. So far, we talked about, cursor doesn't move quickly. We talked about consolidation, right? And then system management, and then software lifecycle. So those are benefits, and another additional one is application availability. The recovery from failure can be done fast and automatically from the cluster. You can have a condition statement, and when certain workload is greater than certain threshold, the process can be spun, or another machines can be spun. The application behind the user side, the application server side load, it has to be adaptable, and that can be done in a flexible manner. Excuse me. And when this among the many soon later today we're going to talk about the virtualization, how it is implemented. It was in fact introduced many years ago, but it was not so it was not so necessary. It kind of died, and then later for fault tolerance purpose, this is really important. Papers from Stanford group really made that this virtualization can be implemented in a more reliable manner that made people reopen their eyes. And then soon the commercial prototype was emerged. 2008. Remember the Salesforce video, 2009, 2010, AWS, the web services. So that's around the time you can see that this is a VMware, the commercial prototype. So let's talk. Any questions so far? So let us talk about a little more specifically. We talked about what is a virtualization in this context. It's about software implementation of entire machine, including operating system, right? But here, here's a more it says informally, but a little more formal description is a virtualized system is a mapping of an interface and all resources visible that through the interface to a real system. So there is a mapping between virtual and real system. By the way, before I talk about this, any virtualization technique, when we say this, or virtualization itself, what are the related terms that comes to your mind? I'm expecting actually the word like simulation, right? Anything else? Any other word that you heard of similar to I already said it. Simulation, emulation. Hard to see the responses reaction. So here I would like to distinguish those here. But actually, let me ask you this question. Since you already heard from me related term simulation and emulation, what would be difference here? Virtual machine virtualization. There's some hint in this slide. Mapping. How about if I try to Benkata? Can you try to say Benkata, are you there? Benkata Naga. We have two Venkatas. Venkata Siva, you're fine too. Yeah. What do you think? It's a totally fine to be, inaccurate. I just want to see what you are thinking. What would be the difference between simulation and virtualization? At least can you respond? I mean, if I were to do attendance based on this type, if I ask you and no response, then yeah, then I could consider you not attending, right? It's totally fine to be wrong, right? I want to hear from you what could be difference between simulation and virtualization.
In simulation, the code is performing the thing what we want to be done in the network. It is executed through the code.
Right, right. That's it. That's what simulation would do. Uh, but what you said could be the case for, it is the case for virtualization as well, right? So, but first of all, do you think there's a difference between simulation and virtualization? Ankita?
Maybe I'm not sure.
I kind of hinted that there is there's some difference. Okay, so there is some difference. The similarity is, as Ankita said, it's done in software, and the things will run as it coded. Okay, um, but one of them uses the abstraction, especially abstraction is both, but the simplification. So which one is more simpler between simulation and virtualization? What do you think? Think about the weather simulation. We don't call it weather model virtualization, right? Weather forecasts, there can be so many different factors in reality, and the whatever model, when we say model, it's actually simplified abstract version of the real thing. The simple abstraction or simplification is what that's a really powerful technique we do in a lot of things, especially in simulation. So simulation, the better simulator would be the one that is closer to the real system. However, due to many different reasons, simulator may not be able to implement all the real things possible, right? Abhinav said the simulation requires one host computer, and virtualization is being performed on a network of computers. It's a good try. Thanks for your response, Abhinav. So the let me say, so simulation is really, simplifies the things. Cartoon, think about the animation movie. These days, a lot of animations are almost like real, but the older the animation or the web cartoon, the a lot of things of real, the images are simplified, right? How the eye was drawn can be just one line, right? So that's really simplified version of your thing. That's what simulation does. And here, virtualization, we are talking about machine virtualization, and let me go back. So the virtualization is a different or a lot more detailed than simulation in a sense that there is one-to-one mapping from the real thing and the virtual environment. So former definition is that construction of isomorphism, one-to-one mapping that maps virtual real host system. So here are two words, guessing. Another keyword is a map. Suppose you are adding numbers in the real program. You are doing a loop. So you increment the I count and you do a loop for, the loop up to 100, you add the sum, the sum equals sum plus I, right? I being from 1 to 100 added. Suppose that is the real program operation. In the not a virtual system environment, there is another way of doing it. You can use a formula, for example, right? How can you add numbers, integer numbers from 1 to n with a formula? N times n plus 1. Let me see. When I do that. Suppose you have a for loop in the, maybe this takes this much time. So for I equals to 1 to, I'm just writing a pseudocode, to 100, and you are like a sum initially assigned to 0, and maybe suppose you are doing it s plus I. This is a one way of doing it. But the another way of doing it is just a 100 s equals n times, what's the other way of doing it? 100 plus 1, right? Do I have a response? Yes, exactly, Ankita. So you can just use that formula, n times n plus 1 over 2. So then these two are not exactly, you know, I don't know how to remove this. Okay, let me share this again. So that's an example where the virtual system and real system are not exactly equivalent. In virtualization, when we say machine virtualization, every operation that is done in a real system, the real system, there should be a virtual mapping as well. Isomorphism between isomorphism mapping between guest system and real system. By the way, look at this when this formal definition was introduced, 1974. Maybe most of you were not even born then, by Popek and Goldberg. So virtualization introduction was that early, and this is a formal definition. Any questions? I didn't have a slide there, but if you are asking a typical question you may ask is that the emulation. Emulation is, it is actually more closer to the real system, but it can be done in the software machine. So I'm not sure if anyone have used the Mininet, that's a network emulator. GNS3, that's a network emulator. So those individual machines and routers are generated in a virtual machine in a single system. So it's a different from real distributed physical systems. However, those are simply they implemented in running in a single machine as a software. In that case, we call it as an emulation. Okay, so simulation being the most abstract and could be simplified version, emulation is closer to the more physical system. Emulation is I'm actually I will be talking later. That can be the way to implement a virtual machine. So stepping back, let's also again talk about history. I really hope that you would appreciate and get excited on in the history. So it was born really early, older than you. Um, so look at these 60s and 70s. There were the computers, not too many big machines. Remember the mainframe computer, mini computer, they were not many mini computer were not mini, it was big, and there was a lot of so-called the client we used to call it terminals. So people used to use terminals to remotely but still typically in the same room access the machine. So this machine is called this. Look at this IBM VM370. They use the VMM for IBM mainframe. Aren't you amazed? So the virtualization was born in late 60s and 70s, and the word VM and VMM was introduced back then. So look at the Popek and Goldberg's paper over here. It was they published in ICM Communications magazine. There were to Popek and Goldberg. Look at this picture, the paper. The title says formal requirements for virtualizable third generation architectures. And read this paper. A virtual machine is taken to be an efficient, isolated duplicate of a real machine. So really, virtual machine was introduced in 74. We explain these notions through the idea of virtual machine monitor. So this is the software that can enable this isolated duplicates of a real machine. And look at this illustration they have done over here. Hardware inside. Typically, as you have seen more modern pictures, hardware goes at the bottom of the layer, and then VMM, and then virtual machine OS application. We do those kind of hierarchy more frequently. But when it was first introduced, this is another illustration. Hardware is at the inside, the wrapper is the software. That's another conceptual way of drawing the idea. And then through this VM is possible. So this is a different kind of illustration. Again, what it says is that it's an efficient, isolated duplicate of the real machine. You might actually get surprised that the word efficient is already there. It's not just the duplicate of your machine. They are isolated. So there can be more than one virtual machines possible on top of VMM or outside of the VMM. And those has to be efficient. If it takes forever, nobody's gonna use it. So the way it is done is there has to be real good, efficient implementation. So IBM was really the leading, and the Popek and Goldberg, they were the leaders in the virtualization. The IBM 370, what they said is a study of multiplicity and usefulness. Any word that comes to your mind, usefulness, meaning that they can increase utilization. Multiplicity, it can have a multiple systems on top, different environment duplicates. This is an IBM systems journal, inside of the IBM journal, but it was IBM back then. It was still, it's a really good company. It's like a Google, the Amazon these days. They were a lot more, research oriented. They have their own the journals and considered very prestigious. And they put they have this the idea there, and also already product made. If you really appreciate, you will be really surprised to see this implement not only the notion but also implementation. 74 was the paper, and then 79 IBM, they already made a product. If you look at this is all amazing. Concurrent execution of multiple production of an operating systems, okay? Testing and development of experimental systems possible. Multiplicity was the embrace here. Adoption of new system with continued use of legacy systems. Isn't it really amazing? That's exactly what, consolidating software, they improve life cycle improvement available by virtualization. In the 70s, they already have envisioned and implemented all this. Ability to accommodate applications requiring special purpose OS, introduced the notion of handshake and virtual equals real mode, right? So to allow sharing of reduced controls information with CP. So as you'll see soon, this implementation, the most tricky part is that sharing of I/O devices like printers, network interfaces, and how can multiple applications running on top of a one single physical machine can share these I/O devices. They already have this system, the notion idea implemented, how to do the handshake, like a button touch from one application to another. Leverage the ability to co-design hardware, VMM, and guest OS. So hardware even, will be co-designed to enable this. It's hardware support for virtualization. That's what it means. This is a really, really amazing thing. Then you might actually wonder why the cloud computing was not earlier, was not introduced earlier. If this concept and some implementation product already available in 70s. Anyone?
Yeah.
So anyone can tell why this was sorry, I had to blow my nose. So anyone can tell why this was you know you'd see that it kind of died out and wasn't used for a long time. And then only 2010 or so um, it was reintroduced, right? 2000, the 2000, mid 2000, it was reintroduced. A lot of technologies is, if you look at the history, it goes through a cycle. So that's a really fun thing to watch. It died. Remember here, it was born early, but it died. I talked about when it was born, the how it looked like when it was born, virtualization, right? Why it was died. Can anyone tell me why it died? Can you guess? No response. Um, So this is just a picture. It's almost like my first computer when I used it in late 80s. This was actually not so the terminal colorful one, but my first computer was really looking like this, accessing this kind of machine, VEX machine. We call it VEX machine. It was uh, so if you have watched the Matrix movie, it shows the green letters on a black screen, right? So that's was here it shows this multi-user environment for a mainframe. So a lot of users could access it together. The reason that virtualization was dead earlier was because of this. What is this? Lack of infrastructure, somebody said. So lack of infrastructure actually could have the flourish the virtual machine because it can enable a lot of users access the machine. Like in older that time, university had a few, maybe one mainframe, and had computer science students to access it using a terminal, right? Um, so still a lot of students can access it together. It's a good thing. But the reason that virtualization died is because of this introduction of powerful computers. Um, yes, and the powerful computer, there's another name called, what is it called? PC, personal computer, right? So personal computer, you don't have to share. It's a powerful enough, and it used previously it was not owned. It was not ownable by an individual easily. Of course, if you were rich, you could do that, but it's not affordable for most of people. But the computer becomes powerful enough, and the cost went down small enough, and everyone could own their own computer, personal computer, and then you don't have to really share multi-user, right? They have their own thing. Hardware, basically no need to share hardware. Uh, and also that CPU, therefore also the CPU didn't support virtualization uh, because the earlier CPU, look at this, right? Leveraged the ability to co-design hardware, VMM, and the guest OS. So hardware could support the virtualization. However, it was not really necessary for individual users, and the bringing costs down was more important than the better enabling uh, the individual PC. So it was dead, but it was reborn uh, because of this old boom of server consolidation, early 2000, late the 1999. The IT infrastructure was necessary a lot, and increasing it's expensive. Um, so how to do more things with less cost-effective way of doing a lot of things, more things, larger scale computing was server consolidation. And also, this is a paper from Stanford uh, that really virtualization software was possible. The For fault tolerance purpose, the paper was called Disco, and the from this late 90s dot-com bubble era, they being located in the Bay Area, they could tap into and actually have a startup. They have a company easily. They founded VMware. So this was really powerful virtualization software that can really support consolidations. VMware is one of the most popular virtualization software. Like our university part of, main part of the data center, we use a VMware too. 2005, this is the IEEE computer, the magazine. Workload, server consolidation, virtualization technology. That was on the title. Dot-com bubble, and going to the bottom, the cost-effective the scaling technology, the they were looking at it, and virtualization is a really way to go. And VMware was already available there as a company. It can reduce the too many number of servers. So that was a big thing. And this is the picture from the edition of the magazine. It says compatible with evolving multi-core architecture. So multi-core architecture was being introduced, becoming more popular. CPU becomes more popular. However, operating systems or the way application was designed was not really fully taking advantage of those the additional the cores available, and virtualization can make the utilization better. Simplifies the software distribution for complex environment, right? The whole system migration workload can be migrated, and in that this can virtualization can improve data center management and efficiency. So really, this is the time that virtual machine monitor was rediscovered. So again, the name, because the 70s paper, they said VMM, the Popek and Goldberg paper called VMM, and it's still called VMM monitor, the passive word. So with this, additions of the services workload can be added easily under the OS. And if you look at this, the systems technologies, the security intrusion detection, fault tolerance, checkpointing, rollback, recovery, all these things can be done more easily, making the services more reliable. So here the picture is a little different from before. Real machine VMM is on top of a real machine, and then here is the virtual machine guest or the virtual machine guest OS, and then application on top. This is another illustration. I'm showing you multiple different illustrations of the concept, so you can easily understand what it means and also be more used to it. And later, when you are introducing a concept or explaining a concept, I want you to be able to have a meaningful illustration on your own as well. So here at the bottom, there is a hardware, VMM, and then operating system and app. So this after the VMware, the first disco paper, there has been a lot of the research community was a spark to do related research. So it was the time of Renaissance was has arrived. The early time when VMware first introduced, starting from the disco paper, is the virtualization technique. Basically, it does full virtualization, meaning that it does entire this implements this concept, and OS can be as is. Guest OS can be as is. So running unmodified OS on top of VMM. So both industry and academia jumped into this, hot, important research topic. When you see this word, running unmodified OS, what do you think? What will come next? Going the opposite way of one thing. Unmodified to, this is really simple question. I want to solicit your responses. So first, VMware virtualization technique is called full virtualization. That means you can kind of guess that later there will be partial virtualization, right? And when you also hear this word running unmodified OS, that means later something will come that runs OS that is modified, right? I'm really soliciting simple, take a hint and think about what will come next. So So that will come soon. But initially, this is a full virtualization. Again, it just does what the picture says. OS is as is. It doesn't really have to understand it is running on top of VMM, right? That's a great thing. But just like, the Olympics or in computing, the history all the time. We want to do faster, better, So there is always the ways to find the limitations, and the next evolution of the technology is to address those limitations. So that was the late 90s, 2003. I don't know what you were doing 2003. There was a gen was introduced. It's a research paper. You see SAWSIP? SAWSIP is the System Operation Conference. Um, this paper was also published in SAWSIP, right? 2003, Zen paper was published, and it is from University of Cambridge. So Disco paper, at that time, the culture was not really open source, but this paper, they made all this great thing and made the source open to the public. That really sparked amazing contribution, interest in the community. They introduced the concept called para-virtualization. Do you guys see that there will be a lot of quiz questions, full virtualization, para-virtualization, unmodified OS, modified OS, these things. So those are the keywords, keep in mind. So Zen introduced the concept called para-virtualization. What it does differently from the earlier VMware virtualization is that it modifies OS for a near native performance Linux on x86. So in the older times, x86, the Intel x86 enabled like a Dell computers that runs Windows operating system. Linux was originally from, it was the PC implementation of Unix, and the Unix was Unix is operating system for workstations. The Macintosh was the chip, and the operating system was, Mac OS. So CPU chip, operating system, it was all the vendors back then. And now through Zen, Linux, which is the flavor, the variant of Unix that you're supposed to run, that used to run on workstations like a Sun, Oracle workstations, could be running on PC x86 Intel chips, right? So that was possible. It's a big change. And because of this open source, the research, the virtualization research comes into Renaissance era. So many people contribute to this area. This one also, because it has a great systems, the systems idea can be easily, well, not so easily, but it's relatively easily translated into the industry. So that became, it wasn't completely open source, was managed, they acquired by a company called the Citrix later. Even these days, later we are going to have about Azure that talk about the open source. So you might wonder, even Google file system, they publish a paper, and then um, because of the paper, the engineers in Yahoo, they implement the Google file system, becomes a Hadoop file system. So those things, and then open source, it becomes an open source, then other people will have a secret too, right? you might wonder that then you might lose the secret sauce of your industry. But in fact, if you are the only one who has the secret sauce, nobody's gonna use it. You cannot get the critical mass. You make it open. Also, you do the related the further enhancement to have your own, and that will be your company. And the other, the other variant will be continue to evolve in the open community. Sometimes, there can be, uh, you know, the interaction from the industry proprietary version to the open source, and so on, the back and forth, vice versa. So that's how the industry is evolving, collaborating, uh, the the toward the evolvement. That's how it is happening. Anyway, the virtualization, you see, the virtualization is one of the initial enabler of the open source community. So the ACM magazine was the IEEE magazine, ACM magazine was featuring virtualization is becoming a big thing. And of course, it can save a lot of money for industry. That's a good thing. Server consolidation, it's better enabled. People start to use it. Then hardware companies like Intel, AMD, oh, this is a good thing to have for us too. This is another way to increase their revenue and support their customers. So the hardware vendors uh, started to implement virtualization at the hardware level. As you will see, it's very tricky to figure out whether this application running program is about to use a hardware resource or not. And if hardware can actually take care of all those things, then software can be made a lot simpler. So this is a big, support from hardware. Uh, then the performance can be near native. Remember from even 69 paper, the uh, efficient isolated duplicate, that's what they talked about. When you implement this concept, it can be very, very slow. They knew that. And make this implementation efficient is the key enabler, and really hardware support made it possible. And these days, hardware virtualization support, it has become default. Late 2000, now cloud computing era, through the virtualization, cloud computing infrastructure service was possible. So again, this is an engine enabler of cloud computing. Um, and also it's also beyond the cloud computing for desktop, remote desktop management and other, the enterprise environment. This can be very helpful. So you look at the cloud computing history from the cloud computing perspective, but also when you look at the individual technology, how it can help, of course, cloud computing, but it can also be helpful for other aspects, other part of the industry as well. Any questions? Let me try to get the responses so far. What comes to your mind? What's the most interesting thing that you see? Can you guys type on the chat? IBM Systems Journal. Okay. I want to hear your responses, right? Maybe VMware, when we was found, how it was found. A lot of companies here, it is started from academia. Like later we'll see CDN coming from the MIT, school. The professor student team, they started the CDN before, actually in 90s, before we have this way before we have Netflix. So the how the academia research contributes to industry, uh, and industries take also motivates the academic research as well. So it's really interesting to see the how the stories are unrolling over time. Okay, thanks, Ankita. History is fun, right? Now let's talk about the second part of the virtualization. So that's a big part, very high level, and the we are going to talk about the implementation, but still starting with the usage of virtualization, cloud computing. Yes, one of them. Server consolidation is another uh, area that virtualization can be used to test and development, high availability, fault tolerance, QA, testing, network product. So, there are so many additional usage of virtualization besides cloud computing. Even if this virtualization is the engine for cloud computing, that engine can be used for many other things as well. And you can, my network emulator, or you can use that as well. It's all used as a virtualization too. Virtualization is if you recall the hype cycle from Gartner, it is anyone can recall where the virtualization technology was in the latest hype cycle. I think that was even 2016, 2015. These days, they don't even show cloud computing hype cycle. They show AI hype cycle. So remember the Gartner's hype cycle, there is uh, the triggers of technology and the peak of disillusionment, valley, trough, right? The and the slope of enlightenment, the final is a plateau of technology, more mature technology. Virtualization was at the plateau. Okay, so it is really mature technology. Now it's offered by many companies, not just VMware, Microsoft, Oracle, there are open source as well. So the virtualization, you can easily start to use it from open source and improve it or modify it as you want. In other words, if you want to do a PhD in virtualization, maybe that's may not be a good idea. I'm not saying that it's not possible, but you might be difficult to publish a lot of papers there. Somewhat more virtualized, but it's still in technology like AI. It might seem more plateau, but there can be some big jump in the growth. We have seen a couple of times in AI already, 2, 3 times, yeah. So, but in general, it's considered as a very mature technology. Hardware support is also possible. Intel VT AMD V for virtualization. If I ask you in a multiple choice question, you should be able to tell. This is the Intel AMD's hardware CPU company. The virtualization support technology. You can find it out. So virtualization is a pretty well-established, mature technology. However, how to handle data, it's still hot research topic, how to optimize it. The big data and analytics platform, they're making things flexible, in making it more suitable for diverse type of analysis, like iterative analysis. Those things are still being evolved very frequently. So, any questions? Now let's talk about the more detail about the virtualization techniques. Okay. Um, some word that you have heard about virtualization. What virtualization have you heard of so far? Remember, VMware initially it started with full virtualization, right? Para-virtualization, those are the words. Another words that I'm introducing here is a type 1 and type 2 virtualization. Again, I'm showing multiple illustrations. So type 1 virtualization is where the hypervisor or VMM runs on top of bare metal. So type 1 virtualization, another name for it is a bare metal virtualization or native virtualization. If it is not native, that means another layers in between. That means that the performance can be worse. So type 1, if you look at the VM, the VM and hardware in between only hypervisor. So you can see that this can perform better. Initial Zen, VMware ESXi, Hyper-V, these are the examples of type 1 virtualization. This is another illustration. Hardware, hypervisor, OSs. Okay. Type 2 the type 2 virtualization is a little different here. What's right on top of a hardware? This is a very simple question. I just want you to be alert, awake, following what I'm talking about, right? In type 2 virtualization, what box is on top of hardware? OS. Yes, thank you, Ankita. Thank you so much. Otherwise, I would feel that I'm just speaking to nobody. So hardware, there's a OS, just a regular OS. And then on top of OS, you're gonna have applications running programs, that in other words, processes, right? Processes running. As one of the processes, it can be a hypervisor. Hypervisor enabling different virtual machines. So there are two OSs. OS on the bottom right above the hardware, and then OS the above higher up, that is above OS, above the hypervisor. Of course, this virtual machine will include OS, and that is guest system or guest OS. Okay, so this type 2 virtualization, another nickname for it is a hosted virtualization. VirtualBox, virtual PC, VMware Workstation. So VMware initially started with a full virtualization, but they also quickly had a hosted virtualization as well. So they have a different versions. In fact, most of the virtualization company has different versions, multiple versions. So yeah, this is the the virtualization. If you were to use excuse. If you were to use virtualization on your desktop, on your laptop, it's likely to be this one. Please. Can I have a show of hands? How many of you have used virtual, how many of you have used, oops. Okay. How many of you have used type 2 virtualization? Okay, Ankita, just one? Really? It should be more than one, I believe. Uday Deep, have you used any virtualization? Bhavita? By the way, I want you to they type something at least once during the class. Otherwise, this can be our quiz, meaning just attendance. Okay, so I want you to type something within 2-3 minutes. Okay, so tell me if you. So let's see this. Everyone, at least type whether you have used virtual machine or not. So it's a yes, I have. No, I haven't. Right? Then it will be your attendance quiz today. VirtualBox. Yeah. I wonder what you have used. The virtual PC, VirtualBox, VMware Player. Again, this is your today's quiz. VirtualBox. And I guess the most of the usage was the Windows or Mac, Linux VirtualBox or virtual PC, right? So keep typing before you leave. Okay. Again, that's today's quiz. This is a different virtualization the layer. You can think about the question, yes, no question. Can one hardware have more than one operating system? Answer is yes, of course. We can have a virtualization, right? Can one OS have a multiple apps? Yes, of course, right? The This is just a different ways of looking at the levels of virtualization. So in type 1, hardware, type 1 hypervisor, virtual machines, OS, and applications. Type 2, hardware, OS. Type 2 hypervisor. You can actually have an application on the next right over here too, right? And on top of hypervisor, you can have multiple virtual machines that runs guest OS and applications. There are some names that we talked about. Hosted virtualization is type 2. It's also called OS level virtualization. Okay. Full virtualization, it is type 1. Oops. VMware ESX server is something. I don't know about you. I usually watch the car plate when I drive in front of my car. What is car plate? I happen to notice ESX a lot, right? And I keep thinking VMware virtualization. So VMware ESX is a full virtualization. On a different dimension, the hardware virtualization can be supported. If so, that is from the either Intel VT or AMD V. And then there is a para-virtualization. We talked about it, right? Para-virtualization, it is also type 1 virtualization, but that's what Zen has first introduced. And what was the purpose of having para-virtualization? Maybe we didn't talk about it yet. Remember, full virtualization, it enables unmodified guest OS. That, in other words, para-virtualization, it does require modified operating system. And the purpose actually it is for performance enhancement. So we'll talk about it more later. Let's see. Before we end, question from Krishna: can we use Heroku, Netlify for static website? Yeah, of course. You don't have to use GCP, AWS, Azure. You can use any different, the cloud service provider for assignment too. Yeah, you do have a freedom. Okay, so let me stop here for today. I hope everybody at least responded. Okay, thank you everyone. If you have any question, want to talk to me after class, please write me a chat now. Otherwise, I'm gonna end this Zoom session. Oh, before you leave, I want to take a quick note on this. No leaving yet. Okay, you guys can leave. I have written it down. Okay, thank you, everyone. Hope to see you in class next week. Okay, I saved the chat. Bye, everyone.